started with the collaboration with PIAM, so we will do that then. But let's now first look at the basic functionality. You can come closer and you can then try it out yourself. So try out the sand. What we are using for the models, well, we have experimented with many different materials, but we have found that this kinetic sand that you can get in toy stores, you can get it in Brookstone. I think it's presented as a stress relief because it holds the shape very nicely, and then you can modify the topography and create like new designs, new scenarios. So let's look at what I did here and Anna did here, and you can see 2 people, 3 people can collaborate and they can do different designs. I think that she didn't do really a very good job, so I can fix her stuff. You can see my scanned hand. Now she thinks, oh, we just really put too many out. So go ahead, you can try it, and then as we go through the lab, all of you can give it a try. We use different tools to work with it. You can add things, you can add objects, you can use that little carving tool as well. We use it in classroom as well. So we had the geospatial modeling and analysis class. We used it actually, for example, to explain 3-dimensional data, to explain raster data, how raster works and resolution and things like that. I think that's what Vašek was experimenting a lot with it. It's excellent for explaining topographic analysis.
Like geosciences.
Like geomorphology.
Right.
Explain people what is convex, what is concave, how slope works. Exactly,
Wow.
exactly. So she can then show you also the slope. So you can look at how the slope looks like. We have geomorphons, so that's the landforms essentially. You can look at those as well.
So is there a piece of equipment, like let's say you had LiDAR data captured in the landscape, you had that as like a LiDAR point cloud digital
That's
model.
what this is.
So is there a way to actually kind of like akin to 3D printing with like subtractive, like working in actual material to take a digital model and then create it in a physical form and stand like this?
Yes, exactly, and that's what I will show you, because that's what it is.
I can change that.
Yeah, let me now show the different models, how we make them. We CNC route them, so that means that it's fully automated. So essentially, this is our expert on that. We take the LiDAR data, we process them in GIS to create the model that we like, so that it's smooth, it's clean, it's at the right resolution. Then Brendan takes it into Rhino and creates the control commands for the CNC router, or for 3-dimensional printer. So you will see, for example, this model is 3D printed. And you can see, this one is very fragile, so we are very careful. 3D printing is, the disadvantage of 3D printing is it's small. It's small and rather expensive. We will go and look at some of the other models. Do you have the whole thing? This is 3D printed, with the plastic, so you can have those as well. This is carved. Oh, okay. So what we very often do, because this is stiff, you can't change it. So we would carve it. So this is 3D printed bare ground. Then we put sand on it. This is 3D printed canopy. First return data, and so you can put the sand on it and then create the canopy surface. And we will go and look at one of the models that has the canopy surface on it. Or you can carve it from the CNC routed from wood. So this is wooden, very nice ones. You can paint it white if you want to, but it projects quite nicely on this color as well. This is, for example, Bald Head Island, Cape Fear area, and this has the bare ground and canopy surface, and it's done. What we do here, we CNC route the inverse, so we use it as a mold. So we have, for most of the models, we have the molds. Maybe we can, do you see down there, there is a mold for that thing. So once it gets really destroyed, you get that mold, we put it there and we restore the model.
But can you get the same, like this kind of detail, the kind of
So this is the 3D model.
Yes, you can. So this is CNC routing. So you can see how fine it is. It really just depends on, Brendan, what's the, I think you can go to millimeters. What's the accuracy, or how fine can you go with CNC routing?
16th of an inch.
16th of an inch.
Depending on the platform. So that's like 0.125 millimeters, I guess?
Yeah, so it can be very accurate. Of course, the higher the detail, the longer it will take, and it takes couple hours.
Is that
So,
machine in here somewhere?
at the machine, we have it at design school.
Okay.
And I have found, like most universities, they have it. There are contractors who would do it for you. So you don't really need it. There are even like amateur CNC routing machines that people just build for themselves. So you can do that as well.